Hello guys, trust you're doing fantastic. In today's video we're going to be talking about the excess 3 code subtraction of 9's complement. Now let's look at case 1 where we're going to be subtracting smaller from larger number. Let's go over the rules. Rule number 1, take 9's complement and excess 3 code for the subtract n. So it means we're going to take 9 complements and also we're going to take the excess 3 code. Rule number 2, add it to the -n excess 3 code. So it means we're going to take the excess 3 code for the -n. Rule number 4, if carry is generated, shift the carry to the next bits. Rule number 4, add 3 to the carry generated bits and subtract 3 from the other bits without carry generated. So what this means that in a scenario where we have carry generated bits, we need to add 3. And also if the bits do not generate carry, we need to subtract 3. That's what this rule says, and we're going to see how this is applied. Alright, so the next thing we need to look at, let's look at an example. Alright, so this example says, what is the 9's complement excess 3 code subtraction of 232 from 345? So what this means is this: we are subtracting a smaller value from a large value. So in that case, if we have to write the solution statement, is going to be 345 minus 232, meaning this larger value is the -n and then the smaller value is the subtract n. So according to the rules, we need to take the 9's complement and the excess 3 code for the subtract n. So taking the 9's complement means we have to subtract each and every digit from 9. Okay, so every bit we have in this digit or in this value, we have to subtract from 9. So it means we say 9 minus 2, 9 minus 3, and 9 minus 2. So we have this is going to give us 7, 9 minus 3 is going to give us 6, 9 minus 2 is going to give us 7. Right, so this is how we arrive at the 9's complement. Okay, now the next step says that we need to take the excess 3 code for 967. So taking the excess 3 code for 767, so it's going to be to add 3 to each and every digit, okay, in this number. So we're going to have 7 plus 3, 10, 6 plus 3, 9, 7 plus 3, that is going to give us 10. Alright, so that takes us to the next step. Alright, so after obtaining the excess 3 code, we need to take the BCD for this value, the excess 3 code, and that would mean to represent each of these digits in the equivalent of 4 bits. Alright, so 10 is going to be represented with this bit, which is 4 bit, which is 1010, which is 8 plus 2 is going to give us 10. 9 is going to be represented with the corresponding 4 bits, so that is going to be 8001. So we're going to have 1001, so this is going to give us 9. And then 10, we're going to represent this in BCD, which is going to be represented with 4 bits. So we're going to have 1010, so this is going to give us 10, meaning you have 8 plus 2, so give us 10. So this is how you represent your values in BCD. Alright, so the next step will be to take the excess 3 code for the -n. Remember, this is the -n, which is 345. So taking the excess 3 code for the minor n would be to add 3 to each and every digit in this number. So we're going to have 3 plus 3, 6, 4 plus 3, 7, 5 plus 3, 8. And then we also need to take the BCD of this result, which is nothing but representing each and every digit in this number with its corresponding 4 bits. So 6 is going to be represented by 0, 1, 1, 0, which will give us 6. 7 is going to be represented by 0, 1, 1, 1. This gives us 7. And then 8 is going to be represented by this bit 1, 0, 0, 0. So this gives us the BCD for 6, 7, 8. Now the next step will be to add the result we have gotten from taking the 9's complement of the subtract n and adding it to the excess 3 code of the minor n. Remember, we have to convert everything to BCD before we can carry out the addition. Now let's carry out this addition. It says 0 plus 0, 0, 1 plus 0, 1, 0 plus 0, 0, 1 plus 1 is going to be 0 with a carry of 1. So we bring down the carry at this point. Now let's move over to the next bits. 1 plus 1, it's going to be 0 with a carry of 1, which is indicated with this red ink. So we say 0 plus 1 plus 1 is going to be 0 with a carry of 1. We take it to the next bit, which is represented in this red ink. We say 0 plus 1 plus 1 is going to be 0 with a carry of 1, which is represented with this red ink. So we say 1 plus 1 plus 0 is going to be 0 with a carry of 1, which is represented in this red ink. So we bring down the carry, which will bring it down to this point to be 1. Now let's move to the next bit and perform the operation. 0 plus 0 is 0. 1 plus 1 is 0 with a carry of 1. We say 0 plus 1 plus 1 is going to be 0 with a carry of 1. 1 plus 1 plus 0 is going to be 0 with a carry of 1, which is represented in this red ink, and then we bring down the carry. So if we notice that every bit, every segment of this bit generates carry. This segment of this bit generates this carry, the segment of this bit generates this carry, and this other segment of this bit generates this carry. So the rule says if carry is generated, we need to shift it to the next bit. So in this case, the carry generated in this segment of the bit, we need to shift it to this other segment of the bit. So we have carry shifted to this other bit, other segment of the bit. So in this particular segment of the bit, we have carry generated, so we need to shift it to this other segment of the bit. Now we have the n around carry. So the carry generated in this segment of the bit, we need to shift it, okay, to this other segment of the bit. So we call it the n around carry. So it's added to this part. Now let's perform this operation. So we're going to add what we have here with this carry bit that has been shifted. So we say 0 plus 1, it's going to be 1. Then 1 plus 0 will bring down the 1. 0 plus 0 will bring down the 0. This other 0 will bring it down 0. So we are done with this segment. Now let's move to the next segment. So we're going to add this with the carry that has been shifted. 0 plus 1, it's 1. 0, we bring down 0. 0, we bring down this 0. And then 0 will bring down this 0. Now let's move to this other part of the segment where we're going to carry out this addition with this bit that's been shifted. 0 plus 1, 1, bring down the 0, 0, 0, bring down the 0, 0, bring down the 0. So we've gotten the final result, which is this. Now, if you notice, at this point, after this operation that we have, now looking at this result that we have obtained, now this result obtained is a result of the carry that has been generated from each of the segments. So it means every segment generated carry. Alright, so we got this result. So in this case, since carry was generated in every segment of this bit, we need to add 3 to it. It means the result we've obtained, this result we're going to add 3, this result we're going to add 3, and this result we're going to add 3. So this is the rule. So this is rule number 4. Alright, so now let's perform this operation. 1 plus 1 is going to be 0 with a carry of 1. We say 1 plus 1 plus 1 is going to give us 1 with a carry of 1. So we say 1 plus 1 plus 0 is going to give us 1. Then 0 plus 0 is going to give us 0. Now let's move to the next segment. 1 plus 1 is going to give us 0 with a carry of 1. 1 plus 1 plus 1 is going to be 0 with a carry of 1. Now 0 plus 1 plus 0 is going to give us 1. 0 plus 0 is going to give us 0. Now let's move to the next segment. We have 1 plus 1 is going to be 0 with a carry of 1. 0 plus 1 plus 1 is going to be 0 with a carry of 1. 0 plus 1 plus 0 is going to be 1. Then 0 plus 0 is going to be 0. Now we've obtained our result, which if you have to represent this in decimal, this is going to be 4. And this is going to be 4. This is going to be 6. Alright, so if you have to subtract 3 from this value, you will say 4 minus 3, we're going to get 1. 4 minus 3, we're going to get 1. And then 6 minus 3, we're going to get 3. So therefore, 446 is the excess 3 code of 111. So this is your answer. Alright, so this result, which is 446, it's nothing but the SS3 code of 111, which is this. So if you've gotten to this point, it means you have gained sufficient knowledge in BCD and SS3 code subtraction of 9's complement, considering case 1. So I'm going to encourage you to pay attention to the subsequent videos in this channel. Alright then.